All right, so let's go through some of these trig ratio problems. We're actually doing some solving now. All right, so example 4 says use trig ratios to find distances. A plane takes off, climbs at a 12-degree angle. Is that angle sufficient enough to fly over an 11,088-foot mountain that is 12.5 miles from the runway, or does it need to increase its angle of ascent? So they're basically saying this distance here is 11,088 feet. They want to know if he goes at 12 degrees, is the plane going to clear the mountain? Okay, so pretty reasonable. We do need to do a little unit conversion here because this is in miles. That one's given to us in feet. So you got your, what do we got there? 12.5 miles. So 12.5, whoops, times 5,280 feet per mile is 66,000. Okay, so this is 66,000 feet. Just the way we can compare answers, make sure things make sense. All right, so at this point, let's solve this triangle, figure out what this number is, and see if it's big enough where they're going to clear the mountain. So if we're looking at our 12-degree angle, we want this opposite leg. We know this adjacent leg. So opposite and adjacent means this should be set up as a tangent problem. So we would do tangent of 12 equals x over 66,000. And so again, the process of what you're thinking of here is using the sides that you want and know to pick the correct trig function, sine, cosine, or tangent. In this case, we know it's tangent because looking at this angle, we don't care about the hypotenuse. We care about the leg and the other leg. All right, so now we need to solve this. Tangent 12 is just a number. So any type of calculator should be able to do trig functions. And I'm going to go around to, I think they were doing 4 places in the assignment. So let's do that. So point 2126. All right. And then generally just going to solve this using cross multiplication, right? So multiply there, you're going to get x, and then 66,000 times that decimal. A lot of times I'll just leave it right in here and get our value that way. So 14,028.73. And again, that's in feet. So that's telling us that this distance right here is this 14,028. And basically, it is going to clear the mountain because the mountain is here at like 11,000. This is going to be up high enough. So it is all good. So do they need to increase its angle of ascent? No, they don't. All right, so now they give a very similar question here. So the plane climbs at 5 degrees and it flies 20 miles through the air as it climbs. What is the altitude of the plane up to the nearest foot? All right, so draw a picture for this. So if we draw this out, we got our plane down here, right? Plane looking good. Perfect. Glorious plane there. It's going at 5 degrees, 20 miles through the air. All right, and then they do want our answer in feet, so I'm going to go ahead and convert that. So 20 times 5,280 is that many. So 105,600 feet. 105,600 feet. And if you look at why I put the number there, is because it says through the air. This is the flight through the air. This would be ground distance. This would be altitude. So read carefully to know what term you're getting. The question wants the altitude, so they want this value. So now we look at that and we decide which trig function is being shown here. If I look at my angle, I want the opposite and I know the hypotenuse. Opposite and hypotenuse is sine. So sine of 5 degrees equals x over 105,600. Okay, and then just like our other problem, sine 5 is a number. So we just type that in. 0.0872. And this is going to solve just like the last one did, where we can put this over 1 and we can cross multiply. So take our value here, multiply by 105,600. And x is 9,203.665 if we round it. Oh, nearest foot. Sorry, I guess I should make that a 4. My bad. There we go. So 9,204 feet. One thing too, I don't know if I kind of forgot if I mentioned this on the last video or not, but you do want to make sure you're in the correct mode on these. When you're doing things like sine 5 and tangent 12, your calculator in the mode section here does need to be in degree. We'll learn about what radian is actually in a couple days. Radian is based off pi. Degree is based off degrees, like 5 degrees, 12 degrees, etc. So you do want to make sure you have degree highlighted. Otherwise, you are going to get not these same values I'm getting. All right. So here's a couple solving for side problems. Here's a couple solving for angle problems. So to find missing angles, we actually use inverses, which, as they say here, inverses are sine -1, cosine -1, tangent -1. These are in our calculator, and it's just second the operation to get it. So if you want to do sine inverse, you just go second sine inverse, and you'll see it makes that same little thing on there. So that's where it's at, but let's go ahead and set these up and figure out how to solve them. So this says find the measure of angle A. Here's A. You know the adjacent, and you know the hypotenuse. So adjacent and hypotenuse sounds like a cosine problem. So cosine of A is 1/4. And at this point, our variable in this problem is angle A. We don't know how many degrees it is. So what we do, now we use our inverse to figure this out. Because we want to isolate A, we are going to do cosine inverse both sides of this equation. That gets rid of cosine and leaves us with A equals cosine inverse of 1/4. So second cosine, 1/4. And there's our degree. So does it say to round anything specific? No. So let's just say 75.5 degrees. All right, now, technically, we can find angle B now just using triangle sum theorem, because you have 90 degrees here, 75.5 there. You could subtract those from 180 to get our answer. So let's just show that. So if we subtract from the 90 and the 75.5, angle B is going to be 14.5 degrees. But let's go ahead and actually just work it out with inverses too so you can see it. So now you're looking at angle B here. This would be opposite over hypotenuse, so it's going to be a sine problem. So sine of B is 1/4. And we're going to solve it just like the previous problem. We're going to go sine inverse to both sides. So into my calculator, I'll do sine inverse of 1/4. And like we said, it should be about 14.5, and it is. So there we go. 14.5 degrees. Last piece here is more of the same, just different picture. Find the measures of an angle. And what you want to get in your head at this point right now, like before we go through and do these, is if you're solving for an angle, you're going to always use inverse, sine, cosine, or tangent. When you're solving for a side, you're going to be getting some decimal and then cross-multiplying to solve. That's going to hold true for any of these. So solving for sides, get the decimal, cross-multiply. Solving for angles, set it up, use the inverse to get your answer. And that should get you through pretty much everything today. So what's the measure of angle P? If I'm looking at P, I know the opposite and the adjacent, so I'm going to go tangent. I'm going to say tangent P equals 2/3. And solve it with the old inverse. So I'm going to inverse both sides, and I'll get P that way. So second tangent, 2/3. Answer about 33.7 degrees. Okay, so at this point, I can find Q. I can just take this away from 90 because, you have 90 degrees here, which means you have 90 split between those two. So if I wanted to, I could say it's going to be 56.3, and I could be done. But again, mainly for the practice here, we'll go ahead and set it up. So if I'm using Q, I'm going to use tangent again, but now it's going to be 3/2. And then I'm going to tangent inverse both sides, just like last time, and get that value. So tangent inverse of 3/2 is 56.3 degrees as expected. So Q, 56.3 degrees. And there we go. So a lot of little things kind of come together on these problems, but the basics are set up the equation and then solve for wherever the variable is at. If the variable is an angle, you're going to use the inverse to solve. If the variable is one of these sides, then you're going to just simply solve by cross-multiplying. And that's pretty much it. So you're going to see some of these today. We'll get into the kind of what I would call the new stuff tomorrow. This is all stuff that was technically from geometry, but it was from kind of those times where we were off, last spring. So try the problems, and hopefully you're feeling pretty good.